projections for global warming become more accurate. If 1 is the loneliest number, 2 is the worst. Mankind must not allow the global temperature rise to 2 degrees Celsius, says the Paris Climate Agreement. Intersection of this line will mean disaster. A particular problem in the study of climate uncertainty. We can't predict when that will happen, because in this massive and complicated system of thousands of variables. But that may change. Recently in the journal Nature published an article in which researchers said they were able to reduce the uncertainty of the key metrics of climate change on 60%, narrowing the range of possible warming from 3 to 1.2 degrees Celsius. In addition, the new data paint a very scary picture of the climate crisis. You can even call it cautiously optimistic. This metric is called the equilibrium climate sensitivity, but do not be afraid of the name. In fact, this level of global warming which we could predict, if doubled carbon dioxide in the atmosphere and given the atmosphere and climate to reach equilibrium with carbon dioxide, says lead author Peter Cox, studies climate system dynamics at Exeter University. Over the past 25 years, the commonly accepted range of potential warming was between 1.5 and 4.5 degrees Celsius. It is quite a big range, given that even 1 degree can change the world. This, for example, 5 to 10% less precipitation during the dry season in the Mediterranean, in the southwestern North America and southern Africa. Bring the warming to 3 degrees, and the Earth will lose 100 square kilometers of wetlands and dry lands. We are talking about an incredibly complex system with a galaxy of variables. Climate scientists are working to narrow the equilibrium climate sensitivity or, as they put it, to limit it. Because it's so big, is that one camp argues that the warming will be minimal and experience is not necessary, and the other we worry that warming will be serious, and therefore the coming catastrophe, and we don't do something. You can try to narrow this range by examining the historical events of warming. But Cox and his colleagues simply ignored the warming trend. It would seem that the obvious thing to do is to study the climate change that has already occurred. But it turns out that this is a bad limit to equilibrium climate sensitivity, primarily because we don't know how much extra heat we have included in the system. Of course, scientists know quite a lot about classical greenhouse climate change, carbon dioxide and methane. But humanity is drugged and other particles in the system and they cool the system. Factories that burn fuel, for example, emit sulfur dioxide, which leads to the formation of particles in the atmosphere, which repel the sun's energy back into space. By the way, this method may help us to cope with climate change. Not by burning fuel, but by adding particles in the atmosphere. The scientists' approach to this study was to combine model 16 in total, not a warming trend, and with how the temperatures range from 1880 to 2016. In fact, these models tell us about the relationship of temperature variations and climate sensitivity, and observations tell us about the temperature variations in the world, says Cox. Together they allow us to better assess the climate sensitivity of our planet. Now to the numbers. Researchers have identified a range of climate sensitivity of 2.2 to 3.4 degree. Compare this with a conventional 1.5 to 4.5. 2,2 at the lower end will definitely not be a good future for our planet. For every degree of warming we can expect a 400% increase in the area burned by a forest fire. Not exactly ideal. Scientists say that the probability that the warming will be less than 1.5 degrees less than 3%. However, the probability that warming will exceed 4.5 degrees, less than 1%, and that's good news. Climatologist Ritu asks an interesting question. What is the probability that in our models there is a mistake? Is it less than 1%? I would say that there is more than one chance in 100 that in all the models might have missed something, because our understanding is not complete. Not that these scientists are poorly versed in science. Just the global climate is an extremely complex problem. No single scientist can understand all of the details of the integrated system, changes in vegetation, small-scale hydrology, every single weather phenomenon, be it a hurricane or a tornado. So scientists are looking for simplified descriptions of these small-scale events. In the case of clouds, for example, you say, well, the higher the humidity, the more likely the rain, and if the saturation exceeds 95%, it's raining, says Nutti. This is a special way to describe the rain, without going into a detailed description of the formation of rain, because you don't do this. The questions are becoming more and more uncertain when the solid observational data cease to be solid. Take, for example, the temperature of the ocean surface. Historically, that different vessels have used different methods, perhaps throwing a thermometer in a bucket of water or off the water temperature at the engine in the engine room. Here you can calculate the divergence of the method with a bucket inaccurate, because the water evaporates, and with the engine because it heats the water, but there is always a chance to lose something from sight. Therefore, scientists work with what we have, and with each new study of the rapidly changing climate of their understanding grows. We are getting better, says Nutti, but will never be perfect. The chance that something is calculated incorrectly, systematic, we cannot rule it out. However, there are reasons for optimism, although the study conducted last summer showed that humanity has almost no chance to raise the temperature by 2 degrees. The new restrictions will change this forecast. Now we can avoid this increase, although, of course, need to take some effort.